Okay, so let's go ahead and get started. First of all, I want to go over the upcoming calendar for us because our schedule is about to get sort of strange. Okay, so the first thing that's going to happen soon is tomorrow, Tuesday the 3rd, is of course Election Day. So please go out and vote. It is, of course, your duty as an American, and this is an interesting election day that we're going to have also. Then next week, Wednesday the 11th. Oh, come on. It seems my ink pen has run out. There we go, maybe. Yes. Wednesday the 11th is Veterans Day. Which is a holiday. We will not be having class on that day. Okay, so that's a campus-wide holiday. Don't expect to be coming to class on Wednesday of next week. Next, the week after that is completely normal, nothing interesting happening, but then we have, starting the 25th, so another Wednesday, is our Thanksgiving break. And that will go until the next week. So the 25th, 26th, and 27th are days that we have off, and then technically we have also the weekend off, which would be the 28th and 29th. And then the 30th we come back. Okay? Now then, once we do get back, let me just make sure I have these dates correct. Yes, okay. So once we do get back, the 3rd, December 3rd, which is a Thursday, is what we call a dead day. Whoops. There will be no class on that day. It is a day that the university basically shuts down all classes and gives you a day to prepare for your exams, which those should start that Friday. Yeah, the 4th. Then the 7th through 9th is the exam period. Okay, so we will have a final exam for this class, as well as Mr. Mrzinski will also have a final exam for his class. And that's it. Now I want to note, though, that the 30th, 1st, and 2nd, that week that we come back after Thanksgiving, all classes will be online. Okay, so after Thanksgiving, there will not be any face-to-face classes, so you guys in here with me in the classroom, don't come to class after Thanksgiving break. It's going to be online. So any questions? No questions? All right. So, that being the case, we don't really have a whole lot of time left with each other. Our class days are numbered. And so we're about to get into the last few bits of college algebra. Okay, so Mr. Mrzinski has started in on chapter 3, and I'm going to pick up where he left off. So he should have gone over the coordinate grid, correct? So Cartesian grid and how to plot points and how to graph things. Okay, so today I want to show us something that we haven't quite seen before. So we've been solving equations. We know how to plot those equations onto a grid. There's a new type of equation that I want to show us. So that would be 7x plus 9 times x plus 8y equals 9x plus y. So this equation incorporates not only x but also y. We have both of these variables that are affecting the equation here. And we want to put it in a particular form. Right now as it is, it's kind of messy, all kind of jumbled up. Our x's and y's are all over the place. We want to put it into a particular form so that it's easier to read and understand. And that form is what's called standard form. And it is ax plus by equals c. So in standard form, this form right here, we have x and y. That's what we have here. We also have a and b. So a is the coefficient of x and b is the coefficient of y. Remember, when I say coefficient, I mean the number in front of that variable. So, you know, we can have things like 2x or negative 5x or whatever. Well, that number right there in front of x is the coefficient of x, in this case a. Same thing for y. b is the coefficient of y, it's just whatever number is out in front of that y. And then c is a constant. C, again, being a constant, is any number, any value that is not attached to an x or a y. We call it constant because, as opposed to variables, which can change, a constant is just only going to be a single value ever. It's not going to have any kind of variation to it. It's always going to be that particular value. Any questions? Okay, so again, what we want to do is we want to take this jumbled up mess of an equation and put it into standard form so that it's a lot easier to understand and read. Well, the first thing we need to do is simplify this equation as far as we can. Once we have it simplified, then we can just rearrange things until it looks like this. So, order of operations. First thing we do is any kind of grouping symbols or parentheses, which we have them, but can we do anything inside of these parentheses? Nah, not really. We have x plus 8y, and well, there's no like terms here. There's no multiplying going on, no powers, no nothing to do in here. So we can move on from parentheses. Next comes exponents. I don't see any exponents. Then comes multiply, and we do have multiplication. We've got a 9 sitting outside of these parentheses here waiting to multiply into them. So let's go ahead and bring them in. So we will distribute that 9 into our set of parentheses. So now we have 7x plus, let's see, 9 times x is going to be 9x. And then 9 times 8y is going to be 72y. And then that's all the multiplication we have. Okay. So we can move on to our next step, which is add and subtract. In other words, combining any like terms we might have. And indeed, we do have like terms. We've got 7x and 9x. So if we combine those two together, we're going to get 16x. And then everything else will just drop down. Nothing else is changing. Okay? And at this point, both sides of our equation are simplified. There's nothing else that we can do on either side. We can't do any kind of powers, add, subtract, multiply, divide on this side. Same thing for this side. Nothing else we can do. So at this point, now that everything is simplified, we can go ahead and start moving things around to make it match this form. Now again, in this form, on this side, we have our variables. We have x and we have y. And then on the other side, we have any constants, which are numbers, values that aren't attached to a variable. So do we have any numbers that aren't attached to a variable here? No, actually we don't. All of these numbers here are associated with either x or y. So we need to take them and bring them over here. All right. So I will subtract 9x, and I will also subtract y. And of course, whatever I do on this side of my equation, I have to do the same thing to this side. So subtract 9x and subtract y. Well, everything on this side is going to cancel, leaving me with what on this side? 0. If there's nothing left, it's 0. All right, this side, 16 minus 9 is going to give me 7. X. And then 72y minus y is 71. And there we go. This is now in standard form. Again, it has all the same information that the original problem had. It's just been rearranged so that it is a little bit easier to understand. It's more clean. But just like our standard form, we have our a, which is 7x, plus b, which is 71, y, equals c, which in this case ends up being 0 because there's no constants. Any questions? Okay. Now another question we can ask ourselves about this equation is it linear? Okay. So what I mean by linear is if we were to graph this on our grid, would we just have a single line, something like that? Or would this line have some kind of curve to it? Would it not be a line, would it be a curve? Okay, so there's a few things that we need to look for to understand if we have a linear equation or a nonlinear equation. So a linear equation isn't going to have any crazy things like exponents. As soon as we see something like x squared or y squared, we know we then have a quadratic equation. And a quadratic equation represents a curve, not a line. So any kind of exponents on our variables would make that a nonlinear equation. But I don't see any exponents. At least the ones that are here are just ones. So that's fine. The other thing is, do we have any fractions? Can we make any fractions out of this? Yeah, I don't see anywhere that we have fractions possible here. I'll show you one where we could get some fractions in just a minute here, but again, this one's just nice and normal. In fact, we can take this from standard form and put it into another form, which is y equals mx plus b, or y equals ax plus b, to fit this form here. So if we wanted to put it into a form that's a little bit easier to graph, well, what we would do is we would, again, change it to y equals ax plus b. In other words, get that b off of y, so that y is by itself. Okay? So we can divide this whole side by 71 to get that off of y, so we get y by itself. Of course, we'd have to divide this side by 71 as well. Well, that would give us 7x over 71 plus y equals 0. And then we move our y to the other side, and we eventually get y equals 7 over 71 times x plus 0. Or, you know, you don't really need the plus 0 part there, but just so it fits our form. Okay? So this is linear. It fits our form for a linear equation, which is y equals ax plus b. Any questions? Okay, so let's try one that isn't linear, does not fit this y equals ax plus b form. It'll fit this, the standard form, but it will not fit the linear equation form. Okay, so I've already simplified this one and put it into our standard form. And in standard form, this one is 9x plus 11xy minus 2y equals 0. Okay, so big thing that's different about this one. In our previous example, once we got down to our standard form, we had it exactly like our standard form, ax plus by equals c. We have an extra term in this one though. We have our ax and we have our by, but we've got this extra thing in the middle here, 11xy. Okay? So what would happen if we tried to make this one into our linear equation form? Again, that linear equation form is y equals ax plus b. Let's try it out. Of course, the first thing we have to do is we have to get that 2 off of the y, but we also got to get the x and the 11 off of the y, and whoa, actually we have 2 y's, so what are we going to do here? Okay, I'll tell you what we're going to do. First, let's get our y's by themselves. Since we have more than one of them, let's get them by themselves. So I'm going to take 9x off of this side. And that gives us 11xy minus 2y. Again, y is what we're trying to get by itself. So let's go ahead and get these things that have y on one side so they're not being jumbled up with anything else. And so this will equal negative 9x. Okay. Well, now there's something interesting here. Both of these have y. And if both of these terms have y, that means they have a common factor of y. So we can go ahead and factor a y off of both of these, right? So we'll go ahead and factor that y out, leaving us with 11x minus 2. Okay, getting somewhere now. So now, again, we want to get y by itself, so what do? It's y times this right now, so what are we going to do to get that off of y? Well, the opposite of multiplying it by y is dividing. So we will divide both sides by 11x minus 2, which gives us y equals negative 9x over 11x minus 2. So, does this look like our form for a linear equation? Do these two things look anything like each other? No. This is y equals ax plus b, and this is y equals ax over something. Okay, it's not a linear equation, and we can tell that because it does not fit the form of a linear equation. Sure, we can put it in the form of a standard equation, but we can't make it into a linear equation. In fact, there's something else going on here too. Think back to what we were doing last week with our rational expressions. If we just have this here, is there anything that I could plug in for x that would make the bottom part 0? Well, yeah, there is. If I isolate that bottom part, 11x minus 2, we know that the bottom of this fraction cannot be equal to 0. Because if it is, then we'd be dividing by 0, and can't do that in algebra. So we solve this, and we get that x cannot be equal to 2 over 11. So if this thing isn't linear, what is it? What does it look like as a graph? I'm not going to spend the time to actually graph this thing out, but I'll show you what it looks like. Okay. If we were to graph this, we would get this really interesting looking shape. Something like this. Okay. So, what's going on here? Why is there two lines? We only have one equation. There shouldn't be two lines, right? Actually, this technically is all the one line. It's just that we have this part right here that it can't cross. Can you guess what this is? This line right here is x equals 2 over 11. This is what we call an asymptote. An asymptote is an area of a graph which cannot be included in the solutions. So the graph cannot cross that line. It ends up, we actually have another one right here. I didn't draw it very well, but we have another one right there. So there's actually also something that y cannot be equal to. Which I'll get to probably Wednesday. Okay, but for today, I just want to show you all the difference between linear and nonlinear equations. Okay, any questions? No questions? All right. So let's try some of these out and see if we can determine now if they are linear or nonlinear. Okay, again, if it's linear, it'll fit this form. If it's nonlinear, it's going to be something screwy like that. So let's try one out. That looks good. Okay. So the one I have here, again, I'm just pulling this off of Hawks, is 9 plus y, quantity squared, minus y squared, equals minus x plus 2. Okay, so remember, one thing that I said about equations is if we want them to be linear, they can't have powers on them. They all have to be power 1. In other words, the expression on this side of the equation needs to be degree 1. Okay, so we've got some powers here. Let's see what happens when we actually start simplifying this, and let's see if we come up with a linear equation. All right, well, to start off with, of course, we want to simplify this, and then let's go ahead and put it into standard form. So following our simplifying process, what do we need to do first? Think about your order of operations. Okay, well, we have parentheses, but can we do anything inside of those parentheses right now? Nah, we can't. Okay, so let's move on from parentheses. Do we have exponents? Yeah, we do have exponents. Now this y squared here, can't really do anything with it, but this one right here, 9 plus y quantity squared, we can go ahead and square this whole thing out. Of course, this means that we are multiplying 9 plus y by itself. Okay. So if we were to multiply this out, we would get 81 plus 18y plus y squared. I've already multiplied it and simplified it for us here. And we can drop down the rest of this. So negative y squared equals negative x plus 2. Okay, so we did our exponents. Do we have any place that we can multiply now? Do we have any place that we can divide? I don't see any place that we can multiply or divide, so let's move on. How about add and subtract, combine like terms? Yeah? What do we have? We have what? Y squared, yeah. We've got positive y squared and negative y squared. Well, wait a minute. If we combine these, what do we get? They cancel. They're gone. So we just have 81 plus 18y equals negative x plus 2. Well, it seems like our powers are gone now. Everything's back down to degree 1. So looking good for this one to be a linear equation. All right. Let's keep going though. Both sides are simplified, so now we want to get it into the form ax plus by equals c. So let's see here. We need to move some things around. Well, by is already in the right place, but x isn't in the right place right now. We need to move it over here. And 81, what kind of thing is it? Is it an a? Is it an x? Is it a b? Is it a y? Or is it c? Well, you can tell if it's an a or a b because it would have either x or y on it, right? Well, it doesn't have x or y on it, so what does that mean this thing is? It's a c. It's a constant. So it's got to move to this side. So we need to move x over here, and we need to move c over here. So add x, subtract c. Okay, so again, add x, and subtract c. So that's going to cancel, that's going to cancel. And we have x plus 81y equals, let's see, 79? Negative 79? Okay, so there it is in standard form. So now, let's try putting this thing into linear form. Let's see if it fits the linear model. So first things first, we want to get y by itself. Let's take x back over to this side. It's going to give us 81y equals x plus negative 79. And then divide by 81 on both sides. So that gives us, well, y equals 1 over 81x minus 79 over 81. So does this fit the model y equals ax plus b? Yeah, it does. We have y equals, our a is 1 over 81, then there's our x, minus 79 over 81 is our b. So, is this linear? Yes. If it fits a linear model, then it's a linear equation. If we were to graph this, we would get a straight line. We wouldn't get any kind of like screwy curves and things like that. Does this make sense? Okay. Good. We'll try another one. Ooh, that's a good one. (10x) plus 4xy equals equals 6y. So you could probably make your guesses right now. Do we think this one's going to come out to be linear or non-linear? Non-linear? I'd actually agree with that. I don't think this one's going to come out to be linear, but let's just check and make sure. Now the reason I don't think it's going to come out to be linear is because we again have the xy term. However, if there's a way for us to get rid of that xy term, then it would be linear. So again, let's go ahead and just check and see. Okay, well, we can not do a whole lot to simplify. It's already simplified. So we can try to make it fit our linear model, get y by itself. So divide by 6 on both sides to get that y by itself. And that means we then have 10 over 6x plus 4 over 6 xy, and of course we can reduce those fractions. What will this one reduce down to? 5 over 3, good. So y equals 5/3 x, and then what will 4/6 reduce down to? 2/3, good. All right. Now it looks kind of like a linear equation, doesn't it? Now remember, our linear equation is y equals ax plus b. So we do have y equals, we do have ax, but do we have plus b? Can we call this b? No, why not? It's not a constant, yeah. B, if it's by itself, if it doesn't have any variable on it, then it's a constant. Well, this has variables on it. It has x and y on it. And so, yeah, this is no longer a linear equation. This is another one of those things that it has those asymptotes. Okay? And in fact, we actually have not solved for y here. We've just kind of force it to kind of look like a linear equation. Because why would I say this isn't solved for y? What's wrong here that it's not solved for y yet? Yeah, there's another y, of course. Good. So yeah, I was trying to trick y'all. I was trying to make it look like it was a linear equation. But yeah, it's not actually solved for y yet because we have another y here. So let me take some steps to actually fix this and make it solved for y. So I'm going to have to take this back to the other side. So now we have negative 2/3 xy plus y equals 5/3 x. Then we can factor a y out. Oops, not yet. Y times negative 2/3 x plus 1 equals 5/3 x. So then we can divide by this term here, and now we have y solved for. Y equals 5/3 x all over negative 2/3 x plus 1. This is the actual solved form. Good eyes. Any questions? Okay, good. I guess we could probably fit in one more. Oh, that's a great one. Let's try this one out. So again, we want to determine if this is a linear equation. So we've got 2x minus y over 5 plus 12y equals 10. Okay. Well, first things first, we've got a fraction in this one, don't we? And what could we do here to get rid of that fraction? Yeah, multiply. In fact, we'll have to multiply this entire side by 5. So that'll just get rid of the 5 here, leaving us with 2x minus y. But remember, we have to multiply this by 5 as well. So 12y times 5 is going to give us what? 60y, good. And then 5 times 10? 50. Excellent. Okay. So, again, we want to simplify anywhere that we can. So can we simplify here? So is there any multiplication that we could do? No. Is there any combined like terms that we could do? Careful, there is. We have negative y and we have 60y. Good. So we can combine these two terms together to give us 2x plus 59y equals 50. Okay. And again, we want to get this into a linear form. We want to make it look like a linear equation, which is y equals ax plus b. So let's get this y by itself. What's the first thing we need to do to get that y by itself? Oh, we could divide by 59. There's something else I would do first, though. Yeah, I'd move the 2x. So that's going to give us 59y equals negative 2x plus 50. And yeah, now we can divide that 59 Okay, so now we have y equals negative 2 over 59 x plus 50 over 59. So does this look like this? It does? Okay, so is it linear? Yes. So we have our y equals, just like we have here, a x, so negative 2 over 59 x plus b. And so yes, indeed, this is a linear equation. Excellent. Any questions? Nope. Okay, good. So once again, if we want something to be a linear equation, it has to fit the linear model. It has to fit y equals ax plus b. Okay? However, equations don't have to. They can also fit the standard form, ax plus by equals c. In fact, both of these are a linear equation, just rewritten in a different way. Okay? But if we try to go from one of these to the other and it doesn't really work, then we need to go back and look and see if we really do have a linear equation. Alright, so Wednesday we will be taking a look at, where did that one go? At that. So again, we know why we can't cross this line, but why can't we cross this line? That's what we're going to be looking at on Wednesday. Until then, I hope you have a good day, and I will see you later. Oh, and I'll have our quiz grades tomorrow.